Hello there, and welcome to Deep Sleep Seas. I'm so glad you found your way here tonight. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to the mysteries of the ocean rather than counting sheep. Either way, tonight's journey is for you. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light, as if the waves themselves are gently rocking you to sleep. Because tonight, we aren't simply learning about marine life. We're drifting into the world of orcas, the social storytellers of the cold seas. Magnificent creatures who speak in dialects, hunt with strategy, and live in families that span generations. Beings who carry wisdom in their songs and knowledge in their ancient eyes. We'll travel gently through their waters, from the icy channels of the Arctic to the temperate coasts of the Pacific Northwest, from pod gatherings to solitary whale songs echoing through the deep. You'll hear of grandmothers and hunters, of languages older than human cities, and of bonds that last lifetimes. Some of what you hear tonight may surprise you, or at the very least spark some curiosity as you drift off to sleep. But before we begin, if you find these stories relaxing, consider subscribing so you don't miss the next deep sea journey. And if you're awake enough, let me know where in the world you're listening from. I read every one. Now let's begin. The orca is not actually a whale, despite the name killer whale, a title given by ancient mariners who witnessed their prowess. Orcas are the largest members of the dolphin family. They belong to the oceanic dolphin family Delphinidae, sharing ancestry with bottlenose dolphins, pilot whales, and other toothed cetaceans. But where their smaller cousins might reach 10 or 12 feet, orcas grow to extraordinary dimensions. A fully grown male can measure nearly 33 feet in length, stretching longer than a school bus, and can weigh up to 22,000 pounds. That's 11 tons of muscle, intelligence and predatory grace gliding through the ocean. Females are somewhat smaller, reaching about 23 feet and weighing around 16,000 pounds, yet they are no less formidable. These are not delicate creatures. They are built for power and endurance in the cold, unforgiving seas. The orca's appearance is unmistakable. Their bodies are painted in nature's most striking contrast. A deep, glossy black across the back and sides, brilliant white on the belly and throat, and distinctive white patches just above and behind each eye. These eye patches vary slightly between individuals, making each orca as recognizable as a human face. Behind the dorsal fin lies a gray or white saddle patch, another feature unique to each whale, allowing researchers to identify and track individuals across decades. The dorsal fin itself is perhaps the orca's most iconic feature. In adult males, this fin can tower 6 feet above the water's surface, a black sail cutting through the waves. It's not just for show. The fin likely helps with thermoregulation and may play a role in hydrodynamics as the whale swims. In females and juveniles, the fin is shorter and more curved, yet still prominent and graceful. These fins are structural, made of dense connective tissue without bone, and they remain upright in the wild throughout the whale's life. Their bodies are sleek and hydrodynamic, perfectly designed for life in the ocean. Powerful tail flukes, horizontal and spanning up to 8 feet across, propel them through the water with remarkable efficiency. Orcas are among the fastest marine mammals, capable of reaching speeds of 34 miles per hour in short bursts. When traveling, they cruise at a more leisurely 6 to 8 miles per hour, conserving energy as they move through their territories. Their flippers, which are large and paddle-shaped, act as steering mechanisms, allowing for precise turns and maneuvers. Every aspect of their form speaks to millions of years of evolution, honing a predator suited for nearly every marine environment on Earth. Inside that formidable jaw lie rows of interlocking teeth, some reaching 4 inches in length. These are not teeth for chewing. They are designed for gripping and tearing. Orcas swallow smaller prey whole, but larger catches are methodically torn apart before consumption. The teeth are conical and curved slightly backward, ensuring that once prey is caught, escape is nearly impossible. An orca's bite force is immense, though exact measurements in the wild remain difficult to obtain. What we know is that they can dispatch seals, dolphins, and even sharks with brutal efficiency. Yet for all their predatory power, these teeth are wielded with precision and purpose, never wastefully, always as part of a calculated hunt. Orcas are found in every ocean on Earth, from the frozen waters of the Arctic and Antarctic to the warm tropical seas near the equator. They inhabit a wider range than almost any other marine mammal. They are cosmopolitan, adaptable, and resilient. Yet despite this global distribution, orcas are not wanderers without home. Many populations are resident, returning to the same territories year after year, sometimes to the same bays and channels their ancestors knew generations before. They know these waters intimately. They remember where salmon spawn, where seals haul out, where currents shift with the seasons. This knowledge is not instinctive. It is learned, passed down from mother to calf, from grandmother to grandchild, a living library of ecological wisdom carried in memory and song. The cold seas are where orcas truly thrive. In the nutrient-rich waters of the North Pacific, the North Atlantic, and the Southern Ocean, they hunt among the most productive ecosystems on the planet. Here, upwelling currents bring nutrients from the deep, fueling blooms of plankton that support vast schools of fish, which in turn feed seals, sea lions, and whales. The orcas sit at the apex of this web, predators without equal, shaping the behavior and distribution of countless other species. They are not just inhabitants of these cold seas. They are architects of the ecosystem, their presence rippling through the food web in ways both seen and unseen. Yet they are not confined to the ice. Orcas have been documented in the Mediterranean, the Caribbean, and the waters off the coast of Hawaii. They move between habitats with ease, some populations migrating thousands of miles, others remaining in relatively small home ranges. What unites them all is their intelligence, their social complexity, and their ability to adapt. Different populations have developed different cultures, different hunting strategies, even different body shapes and color patterns. Some scientists believe these populations may eventually be recognized as separate species or subspecies, so distinct have they become. The orca is not one creature but many, a family of marine predators, each uniquely suited to their world. Sound is the currency of the ocean. In the deep, where light fades to blackness and distances stretch beyond sight, orcas navigate and communicate through a symphony of clicks, whistles, and calls. They live in a world of acoustics where every sound carries information, where silence is rare and noise is meaning. Understanding orca communication is to glimpse a culture as rich and complex as any on land, a language shaped not by vocal cords but by air sacs and tissue structures deep within the blowhole. It is a language learned, not inherited, passed from generation to generation like stories told around a fire. Each pod speaks its own dialect, a unique collection of calls that identifies them as surely as an accent identifies a hometown. Orcas produce three primary types of vocalizations. The first are clicks, rapid bursts of sound used for echolocation. These clicks are not random noise but carefully timed pulses sent out into the water, bouncing off fish, rocks, and the seafloor before returning to the whale. Through these echoes, an orca can perceive its environment in extraordinary detail. It can sense the size, shape, and distance of objects, can distinguish between species of fish, can even detect the internal air bladder of a salmon hiding in murky water. Echolocation allows orcas to hunt in complete darkness, to navigate through kelp forests and rocky channels, to find prey that would be invisible to the eye. The clicks vary in frequency and intensity depending on the task. Hunting clicks are sharp and focused. Navigation clicks are broader, sweeping the environment for obstacles. It is a sonar system refined over millions of years, more sophisticated than anything humans have engineered. The second type of vocalization is the whistle. Whistles are simpler, often rising and falling in pitch, and are thought to function in short-range communication. They are less common in orcas than in some other dolphin species, but they appear during social interactions, moments of excitement, or coordination between pod members. A mother might whistle to her calf. Pod members might exchange whistles while playing or resting. These sounds are gentler, more melodic, carrying less far than other calls, but serving a purpose in the intimate spaces between whales. The third and most fascinating vocalizations are the discrete calls, sometimes called pulsed calls. These are stereotyped sounds, each lasting 1 to 2 seconds, with distinct tonal structures and harmonic patterns. They are the vocabulary of the orca, the words in their language. Each pod has a repertoire of these calls, a collection that can include anywhere from 7 to 17 different types, sometimes more. Some calls are shared across multiple pods, facilitating communication when different family groups meet. Others are unique to a single pod, a signature sound that announces identity across miles of ocean. When you hear the calls of different pods side by side, the differences are immediately apparent. One pod's calls might sound sharp and staccato, another's might be long and wavering. These are dialects in the truest sense, variations in a shared language shaped by culture and geography. Scientists first recognized these dialects in the 1970s, when researcher John Ford began recording and analyzing the calls of orcas in the Pacific Northwest. What he discovered was astonishing. Not only did different pods have different calls, but pods that associated frequently shared more calls than those that remained separate. Pods with similar dialects were grouped into clans, suggesting a common ancestral lineage. Within a clan, individual pods could still be distinguished by subtle variations in their calls, much like siblings from the same family might share speech patterns but still sound distinct. This was evidence of culture, of learned behavior transmitted across generations, of traditions maintained over centuries. It challenged the notion that complex culture was unique to humans and a few great apes. Here were marine mammals, living in a world utterly unlike ours, with their own languages, their own histories, their own ways of being. Calves are not born knowing these calls. They enter the world with only basic vocalizations, high-pitched screams that bear little resemblance to adult calls. But from the moment of birth, they are listening. They hear their mother, their grandmother, their aunts and siblings. They hear the pod's dialect surrounding them, a constant acoustic environment that shapes their developing brain. By the time a calf is 2 months old, it begins producing its first recognizable calls, simple at first, gradually becoming more refined. From 2 to 6 months, the calf's repertoire expands rapidly, adding new calls and perfecting old ones. This is a critical learning period, when the foundations of the dialect are laid down. By the time a young orca reaches puberty, its dialect is largely fixed. It has learned the language of its family, and it will carry that language for the rest of its life. This learning process is not passive. Mothers appear to actively teach their calves, repeating certain calls more frequently in the calf's presence, correcting vocalizations that don't match the pod's standard. Calves practice, making mistakes, trying again, refining their technique until the call matches what they hear. It is a process remarkably similar to how human children learn to speak, through imitation, reinforcement, and gradual mastery. The fact that orcas engage in such cultural transmission is profound. It means that each pod carries a unique heritage, a vocal tradition that can be traced back through generations. When a pod is lost, its dialect is lost forever, a language that will never be spoken again. This makes orca conservation not just a matter of preserving numbers, but of preserving cultures, of protecting the diversity of knowledge and tradition that exists across the oceans. Interestingly, orcas in different parts of the world have developed entirely different acoustic cultures. Orcas in Norway sound nothing like orcas in Iceland, despite being separated by only a few hundred miles of open ocean. Norwegian orcas have been recorded making 24 different call types. Icelandic orcas make 23, but not a single call is shared between the two populations. They are speaking different languages, unable to understand each other's vocalizations, despite being the same species. This suggests that orca dialects are not genetically programmed, but are entirely learned, entirely cultural. It also suggests that orcas rarely move between distant populations. If they did, we would expect to see some mixing of dialects, some borrowing of calls. Instead, we see linguistic isolation, each population developing its own acoustic identity over thousands of years. The dialects serve multiple functions. They allow orcas to identify pod members even when separated by distance or obscured by darkness. A whale hearing a familiar call knows instantly that family is near. Dialects also facilitate social bonding. When pods with similar dialects meet, they often engage in extended socializing, traveling together, playing, and sometimes mating. Pods with very different dialects tend to avoid each other, suggesting that acoustic similarity reflects genetic relatedness and cultural compatibility. The calls are not just communication. They are identity, history, and belonging all woven into sound. Beyond the discrete calls, orcas communicate through body language and physical gestures. A slap of the tail on the water's surface can signal frustration or excitement. A gentle rub between pod members reinforces social bonds. Breaching, when an orca launches its entire body out of the water and crashes back down, may serve to dislodge parasites, communicate over long distances. or simply express exuberance. Spy hopping, when an orca rises vertically out of the water to look around, is a way of surveying the surface world, checking for prey, boats, or other pods. These non-vocal signals add layers to the complexity of orca communication, creating a multimodal language that operates on several levels at once. In recent years, researchers have discovered that some orca populations are also capable of vocal mimicry, learning to imitate the sounds of other species or even human speech patterns. This ability to learn new sounds and incorporate them into their repertoire suggests a level of cognitive flexibility rarely seen in the animal kingdom. It hints at a mind capable of innovation, of experimentation, of cultural evolution happening in real time. The more we study orca communication, the more we realize how much we still don't understand. Their language is not simple. It is layered, nuanced, and deeply tied to the social and ecological context in which it is used. It is a window into a mind we are only beginning to comprehend. Orcas are hunters without equal. They are apex predators, sitting at the very top of the marine food web, with no natural enemies save for humans. Their diet is astonishingly diverse. Taken as a whole, the species consumes more types of prey than any other cetacean. Fish, seals, sea lions, dolphins, porpoises, sharks, rays, seabirds, sea turtles, and even the largest animals on Earth, baleen whales, all fall within the hunting repertoire of orcas. Yet despite this diversity, individual populations are remarkably specialized. A pod that hunts salmon will rarely take a seal. A pod that hunts seals will ignore schools of herring swimming past. This specialization is cultural, learned behavior passed down through generations, a culinary tradition as specific as any human cuisine. In the cold waters of the Pacific Northwest, resident orcas feed almost exclusively on fish, particularly Chinook salmon. These massive salmon, some weighing over 50 pounds, migrate through the coastal waters in seasonal runs, and the orcas follow them with practiced precision. The whales know when the salmon will arrive, where they will travel, and how to catch them most efficiently. They use echolocation to locate schools, coordinating their movements to herd the fish into tight balls near the surface. Once the fish are concentrated, individual whales take turns striking the ball with their tails, stunning or killing several fish at once. The dead and dazed salmon float to the surface, where they are picked off and swallowed whole. It is a methodical, efficient process, requiring patience and teamwork. Every member of the pod knows their role, learned through years of observation and practice. Off the coast of Norway, orcas have developed a hunting technique known as carousel feeding, targeting the vast schools of herring that gather in the fjords each winter. The process begins when the pod locates a school, often numbering in the thousands. The orcas circle the herring, tightening the school into a dense swirling ball. They blow bubbles, flash their white bellies, and slap the water's surface with their tails, all to disorient and compress the fish. The herring, panicked and confused, crowd together for safety. But this only makes them more vulnerable. Once the ball is tight enough, usually only a few meters in diameter, the feeding phase begins. Some orcas continue to herd, maintaining the shape and position of the ball. Others peel away, diving beneath and then surging upward, whipping their tails through the mass of fish. The force of the tail strike is devastating. Fish are stunned, killed, or sent spiraling through the water. The orcas then leisurely pick off the incapacitated herring, swallowing them one by one. After a few minutes, the roles switch. The herders become feeders, and the feeders become herders, ensuring that every member of the pod gets a meal. This cooperative strategy is so effective that it can sustain a pod for months, and it is taught to calves through direct observation and participation. Young orcas watch their mothers and grandmothers, learning the timing, the coordination, the vocalizations that accompany each phase of the hunt. In the icy waters around Antarctica, a different orca population has mastered one of the most spectacular hunting techniques in the animal kingdom: wave washing. Here, seals rest on floating ice floes, safe from most predators. But orcas have learned to create waves large enough to wash the seals into the water. The hunt begins when the pod spots a seal on an isolated floe. The whales approach slowly, assessing the situation, the size of the floe, the escape routes available to the seal. Then several orcas line up side by side, 15 or 20 meters away. On some unseen signal, they swim at full speed toward the ice, their massive bodies creating a wave front as they move. Just before reaching the flow, they dive beneath it, using their tails to give one final push to the wave. The water surges over the ice, tipping it, flooding it, and often washing the seal into the ocean. If the first wave is unsuccessful, the orcas retreat and try again and again. Sometimes it takes 10 attempts, sometimes only one. But once the seal is in the water, its fate is sealed. The orcas are faster, stronger, and infinitely more maneuverable. The seal is caught, killed, and shared among the pod. What makes wave washing even more remarkable is that orcas don't always kill the seal immediately. In several observed instances, an orca will catch the seal in its mouth, then release it back onto another ice floe, only to wash it off again. Or the seal will be tossed between pod members, a macabre game that appears to serve as training for younger whales. Calves watch, learn, and sometimes participate, honing their skills on live prey under the guidance of experienced adults. This behavior suggests that hunting is not just about food. It is also about teaching, socializing, and perhaps even play. The line between work and recreation blurs in orca culture, where the hunt is both necessity and tradition. Off the coast of Argentina, a small population of orcas has developed an even more daring technique: intentional stranding. These whales hunt sea lion pups that gather on the beaches, and they have learned to beach themselves deliberately to catch them. The whale approaches the shore at high speed, riding a wave onto the sand. In one explosive motion, it grabs a sea lion in its jaws, then uses its powerful tail and body to wriggle back into the water. The entire maneuver takes only seconds, but it is fraught with risk. A miscalculation could leave the whale stranded, vulnerable to overheating, and unable to breathe. Yet these orcas perform the technique with astonishing precision, passing the skill from mother to calf through patient demonstration. Young whales practice on shallow beaches, learning the timing, the angle of approach, the use of tides. Adult females sometimes beach alongside calves, creating a safe environment for learning. The knowledge required for this hunting strategy is so specific, so dangerous, that it takes years to master. It is one of the clearest examples of cultural transmission in the animal kingdom, a behavior that would never arise through instinct alone. Orcas also hunt other marine mammals with calculated brutality. When targeting dolphins or porpoises, they use a combination of speed, teamwork, and overwhelming force. The pod will surround a school of dolphins, cutting off escape routes. Then individual orcas will ram the dolphins from below, launching them into the air, or grab them and drag them underwater until they drown. The attacks are not frenzied. They are methodical, efficient, and coordinated. Every whale knows where to be, when to strike, and how to support the others. Even great white sharks, the ocean's most feared predators, are not safe from orcas. In several documented cases, orcas have killed great whites by flipping them upside down, inducing a state called tonic immobility, a kind of paralysis that leaves the shark helpless. The orca then tears open the shark's body to access the liver, a nutrient-rich organ, leaving the rest of the carcass to sink. This behavior has been observed off the coasts of South Africa, California, and New Zealand, always with the same precision, the same targeting of the liver. It suggests that orcas understand shark biology in ways we are only beginning to appreciate. Perhaps most astonishing is the orca's ability to hunt baleen whales, animals many times their size. Blue whales, the largest creatures ever to exist, have been observed with tooth rake marks from orca attacks. Gray whales migrating along the Pacific coast are regularly targeted by transient orca pods. The attacks are coordinated and relentless. The orcas will separate a calf from its mother, then take turns ramming it, biting its fins and flukes, exhausting it until it can no longer swim. The entire process can take hours, sometimes covering miles of ocean. Once the calf is dead or dying, the orcas feed, often targeting the tongue and lips, the softest and most energy-rich parts of the body. The mother whale, helpless and grieving, can only watch. These hunts are not common, but they demonstrate the orca's versatility, its willingness to tackle prey that would seem impossible for an animal of its size. All of these hunting strategies share common elements: cooperation, communication, and cultural knowledge. Orcas do not hunt alone. They hunt as a family, each member playing a role, each contributing to the success of the group. The strategies are learned, refined over generations, and adapted to the specific prey and environment of each population. A Norwegian orca would not know how to wave wash a seal. An Antarctic orca would not know how to carousel feed herring. These are not instincts. They are traditions, cultural practices, as specific and localized as any human skill. And they are taught patiently and deliberately from elder to young, ensuring that the knowledge survives even as individual whales pass away. At the heart of every orca's life is family. Unlike most mammals, where offspring eventually disperse to form their own groups, orcas remain with their mothers for their entire lives. This is true for both males and females, a social structure so rare that it is almost unheard of in the animal kingdom. The core unit of orca society is the matrilineal, a family group centered around a single female, her daughters, and her sons, along with her daughters' offspring. These matrilines can span up to 5 generations, creating extended families where great-grandmothers swim alongside great-grandchildren. The bonds between these whales are profound, maintained through constant communication, physical contact, and shared experiences that stretch across decades. A typical matriline might consist of an older female, often called the matriarch, her 2 or 3 adult daughters, each with calves of their own, and her adult sons, who remain close by despite no longer reproducing within the group. The matriarch is not a leader in the hierarchical sense. She does not command or control, but she is central. She is the keeper of knowledge, the one who remembers where to find food in times of scarcity, the one who navigates the pod through unfamiliar waters. Her experience spans decades, sometimes more than half a century, and that experience is invaluable. When salmon runs fail, when prey becomes scarce, it is often the matriarch who leads the pod to alternative hunting grounds. Drawing on memories from years past, her presence stabilizes the group, provides continuity, and ensures that the family's traditions are passed down intact. Multiple matrilines that travel together and share similar dialects form a pod. In the resident orcas of the Pacific Northwest, pods can include several matrilines, totaling anywhere from 5 to 50 individuals. These pods are not static. Matrilines within a pod may split temporarily to forage or rest, then reunite hours or days later, but the bonds remain strong. Pod members recognize each other by voice, by appearance, by the shared history of countless hunts and journeys. They greet each other with vocalizations, rubbing their bodies together in what appears to be affection and reassurance. Play is common, especially among younger whales who chase each other, leap from the water, and engage in mock battles that strengthen social bonds and teach cooperation. Pods that share a portion of their vocal repertoire are grouped into clans. Clans represent a deeper level of social organization, suggesting common ancestry and cultural heritage. Within a clan, pods may socialize when they meet, traveling together for days or weeks, but they maintain distinct identities. The southern resident orcas of the Pacific Northwest, for example, are divided into 3 pods: J-pod, K-pod, and L-pod. Each has its own unique calls, but they also share certain calls across all 3, facilitating communication and social cohesion. Together, these 3 pods form a community, the highest level of orca social structure, defined by association patterns and shared territory. The community numbers fewer than 80 individuals, a small population that depends on each whale, each matriline, for its survival. The bonds between mothers and their offspring are the strongest in orca society. A calf stays close to its mother from the moment of birth, learning to swim, to breathe, to hunt, to communicate. The mother is patient, protective, and deeply invested in her calf's survival. She nurses her calf for 1 to 2 years, providing rich milk that fuels rapid growth. Even after weaning, the calf remains dependent on her for food, for protection, and for knowledge. Young orcas do not know how to hunt instinctively. They must be taught, shown where prey hides, how to approach, when to strike. This learning process takes years, sometimes more than a decade, for complex techniques like carousel feeding or wave washing. The mother, and often the grandmother, lead this education, demonstrating each step, allowing the calf to practice in safe conditions, correcting mistakes through example. Sons remain especially close to their mothers throughout life. Adult males, some weighing 10 tons and sporting 6-foot dorsal fins, still swim alongside their mothers following her lead, relying on her knowledge. Studies have shown that when a male's mother dies, his chances of dying within the next year increase dramatically, especially if he is still young. Older post-reproductive mothers provide even greater survival benefits, suggesting that their value to their sons extends far beyond providing food. They navigate social interactions, mediate conflicts with other pods, and share fish they catch. Males, for their part, do not mate within their own pod. They seek mates from other pods, ensuring genetic diversity, but they always return to their mother's side. Their loyalty is absolute, their bond unbreakable. Daughters also remain close, though they may travel more independently once they have calves of their own. A mother and daughter might swim side by side for hours, their breathing synchronized, their movements mirrored. When the daughter gives birth, the grandmother often assists, helping to support the newborn calf to the surface for its first breath, protecting it from potential threats, teaching it the calls of the family. This multi-generational caregiving creates a web of support that extends across the entire matrilineage, ensuring that no calf is raised in isolation. Even if the mother is inexperienced or struggling, the grandmother, aunts and older siblings step in, providing the knowledge and protection the calf needs to survive. This matriarchal structure has profound implications for Orca society. Knowledge is accumulated over lifetimes and passed down through generations. Each matrilineage holds a unique set of experiences, a library of ecological and social information that cannot be found anywhere else. When a matrilineage is lost, that knowledge is lost with it. This makes the survival of older females especially critical. They are not just individuals, they are the living memory of the pod, the keepers of traditions that stretch back before any living whale was born. Protecting them is not just about numbers, it is about preserving the culture, the identity, and the future of the entire population. In Orca society, age is wisdom, and wisdom is survival. Females can live for 80 to 90 years, some even longer. Males typically live shorter lives, averaging around 50 years, though some reach 60. This disparity in lifespan is unusual among mammals, and may be linked to the different roles males and females play in the pod. Females are central, stable, the foundation of the family. Males are more peripheral, their primary contribution to the next generation occurring through mating with females from other pods. Yet even in their shorter lives, males contribute to the pod's success, helping to hunt, sharing food, and participating in the social fabric that holds the group together. One of the most extraordinary aspects of orca biology is menopause. Orcas are one of only a handful of species, along with humans and a few other toothed whales, where females live for decades beyond their reproductive years. Female orcas typically stop reproducing in their 30s or 40s, yet they can live for another 30, 40, or even 50 years. This prolonged post-reproductive lifespan is exceedingly rare in the animal kingdom. In most species, females reproduce until they die, maximizing the number of offspring they produce. But in orcas, something different is happening. Evolution has favored a strategy where females give up the opportunity to have more offspring in order to invest in the offspring they already have. This is the grandmother effect, and it is one of the most profound examples of altruism and long-term thinking in nature. The grandmother effect works through several mechanisms. First, post-reproductive females share their knowledge with the pod. They remember hunting grounds from decades past, know where to find food when conditions are poor, and guide the pod through environmental challenges. In years when salmon populations are low, the presence of a post-reproductive grandmother increases the survival rate of her grandchildren significantly. Studies tracking individual orcas over 40 years have shown that calves with living grandmothers are much more likely to survive than those without. When a grandmother dies, the risk of death for her grandchildren increases dramatically, especially for young calves who are still learning to hunt. This effect is most pronounced during times of scarcity, when experience and knowledge make the difference between life and death. Second, post-reproductive females avoid reproductive conflict with their daughters. When both a mother and her daughter are reproducing at the same time, their offspring compete for the same resources. Food, attention, and protection must be divided. Research has shown that when this happens, the older female's offspring are more likely to die than the daughters. By ceasing reproduction, the grandmother eliminates this conflict, allowing her daughters to reproduce successfully and focusing her energy on helping raise her grandchildren. This is not a conscious decision in the human sense, but rather an evolutionary strategy that has been selected for over thousands of generations. Females whose genes led them to stop reproducing early and invest in grandchildren ended up with more surviving descendants than those who continued reproducing until death. Third, post-reproductive females play crucial roles in the social structure of the pod. They mediate conflicts, maintain cohesion, and pass down cultural knowledge that cannot be learned through observation alone. They teach vocalizations, hunting techniques, and social norms. They model behavior for younger whales, demonstrating patience, cooperation, and resilience. In resident orca populations, older females often take the lead when the pod is traveling, especially during difficult conditions. They are followed without question, their experience trusted implicitly. This leadership is not dominance, it is respect, earned through decades of successful decision-making. One of the most famous examples of this grandmother effect was a whale known as Granny, or J2, the matriarch of the southern resident orca community. Granny was estimated to be over 100 years old when she disappeared in late 2016, presumed dead. She had not reproduced in over 50 years, yet she remained central to her family and the wider community. She led the pod through some of the most challenging periods in recent history when salmon populations crashed and food became scarce. Researchers observed her guiding the pod to distant hunting grounds, places she remembered from decades before. Her knowledge accumulated over a century of life was irreplaceable. When she died, the loss was felt not just by her immediate family, but by the entire community. Scientists studying the southern residents noted changes in the social dynamics, the loss of a stabilizing presence that had shaped the lives of multiple generations. The evolutionary mystery of menopause has puzzled scientists for over a century. Why would natural selection favor females who stop reproducing? In most species, the answer is simple. It wouldn't. Reproduction is the engine of evolution, the mechanism by which genes are passed to the next generation. Anything that limits reproduction should be selected against. Yet in orcas, menopause has not only persisted but has been favored, suggesting that the benefits it provides must be substantial. Recent research comparing orcas with other long-lived social mammals like elephants has shed light on this puzzle. Elephants, like orcas, live in matriarchal societies, and older females provide knowledge and leadership. But elephants do not go through menopause. They continue reproducing into old age. The key difference appears to be in the social structure. In orcas, both sons and daughters stay with their mothers for life, creating intense competition for resources if the mother continues to reproduce. In elephants, sons leave the herd at maturity, reducing this competition. This difference in social structure has led to different evolutionary solutions. In orcas, menopause evolved. In elephants, it did not. The grandmother effect is not just theoretical. It has been measured, quantified, and documented in wild orca populations. Researchers have shown that the presence of a post-reproductive grandmother reduces the mortality rate of her grandchildren by up to 4.5 times. This is an enormous survival advantage, one that ripples through the pod and affects the long-term viability of the population. When older females die prematurely, whether from pollution, boat strikes, or starvation, the impact extends far beyond the individual. Entire matrilines can suffer, their survival prospects diminished, their cultural knowledge eroded. This makes the conservation of post-reproductive females not just important, but essential. They are the foundation of orca society, the keepers of traditions, and the guardians of the future. The grandmother effect also sheds light on human evolution. We are one of the few species that undergoes menopause, and the reasons have long been debated. Do we stop reproducing because of modern medicine extending our lifespans, or is menopause an ancient adaptive trait? Evidence from hunter-gatherer societies suggests the latter. In these populations, women regularly live decades beyond menopause, providing critical support to their children and grandchildren. Grandmothers in these societies share food, care for infants, and pass down knowledge, just as orca grandmothers do. The parallels are striking, suggesting that menopause in both species evolved through similar selective pressures. It is a reminder that we are not as separate from the natural world as we might think, that the forces shaping orca society are the same forces that shaped our own. Orcas are among the most intelligent animals on the planet. Their brains are large, complex, and highly developed, particularly in regions associated with emotion, social cognition, and problem-solving. The orca brain weighs around 15 pounds, the second largest among marine mammals after the sperm whale. But size alone does not tell the whole story. What matters is the structure, the organization, and the ratio of brain size to body size. Orcas score high on the encephalization quotient, a measure of brain size relative to body mass. They rank just behind humans and bottlenose dolphins, far ahead of most other mammals. This suggests a level of cognitive ability that supports complex thought, planning, and cultural learning. One of the most striking features of the orca brain is the presence of highly developed spindle cells, also known as von Economer neurons. These cells are found in only a few species: humans, great apes, elephants, and certain cetaceans, including orcas. They are thought to play a role in social cognition, empathy, and rapid decision-making in complex social situations. In orcas, spindle cells are found in the same brain regions as in humans, suggesting similar functions. This raises the possibility that orcas experience emotions in ways we can relate to: grief, joy, frustration, affection. Observations of wild orcas seem to support this. Mothers have been seen carrying dead calves for days, sometimes over 1,000 miles, in what appears to be mourning. Pods engage in what looks like celebration after a successful hunt, leaping and vocalizing in unison. Young whales play for hours, chasing each other, tossing kelp, and engaging in mock battles that serve no obvious survival purpose beyond sheer enjoyment. Orcas are also capable of remarkable problem solving. In captivity, they have learned to perform complex behaviors, follow multi-step commands, and even understand abstract concepts. Wild orcas demonstrate similar cognitive flexibility. They innovate new hunting techniques, adapting to changing prey availability and environmental conditions. In Norway, researchers observed orcas learning to steal fish from longlines, a behavior that spread through the population as individuals watched and imitated each other. In New Zealand, orcas have been seen using kelp as tools, wrapping it around their bodies in what scientists have called a local ping, though the purpose remains unclear. In the Pacific Northwest, orcas have learned to distinguish between the sounds of different boat engines, recognizing which vessels pose a threat and which are simply passing through. This ability to learn, to adapt, and to innovate is a hallmark of intelligence. Cultural transmission in orcas extends beyond hunting techniques. It includes vocalizations, social behaviors, and even fads. In the 1980s, a group of orcas in the Pacific Northwest began carrying dead salmon on their heads, balancing the fish on their rostrums as they swam. The behavior spread through the population, with multiple whales adopting it, then disappeared after a few months. In 2025, the behavior reappeared, decades later, suggesting that cultural trends can lie dormant and resurface. No one knows why the orcas do this. It serves no obvious purpose, provides no nutritional benefit, and requires effort to maintain the balance. It is, as far as researchers can tell, a fad, a behavior adopted for social reasons, for play, or perhaps simply because it is interesting. Play is a significant part of orca life. Young whales spend hours playing, engaging in behaviors that build strength, coordination, and social bonds. They chase each other through kelp forests, toss objects back and forth, and practice hunting techniques on non-prey items. Adults play too, though less frequently. They breach, slapping the water with their bodies in displays of power and exuberance. They surf in the bow waves of boats, riding the pressure wave with precision and apparent enjoyment. Play is not frivolous. It is essential for development, for learning, and for maintaining the social cohesion that underpins orca society. It is also evidence of a mind that experiences the world not just as a series of survival challenges, but as a place of curiosity and joy. The intelligence of orcas raises profound ethical questions. If these animals are capable of culture, of language, of emotions akin to our own, what does that mean for how we treat them? Historically, orcas have been hunted, captured for display in marine parks, and subjected to environmental degradation that has decimated some populations. The southern resident orcas, for example, are critically endangered, numbering fewer than 80 individuals. Their decline is driven by lack of prey, pollution, and noise from boat traffic, all human-caused. Protecting orcas is not just about preserving a species. It is about preserving cultures, languages, and ways of life that have existed for thousands of years. It is about recognizing that intelligence and sentience are not unique to humans, that we share this planet with beings whose inner lives are rich, complex, and deserving of respect. Not all orcas are the same. Across the world's oceans, distinct populations have evolved, each adapted to its environment, its prey, and its social structure. These populations are so different in appearance, behavior, and genetics that some scientists believe they should be classified as separate species or subspecies. Currently, researchers recognize at least 10 distinct ecotypes, though new ones are still being discovered and described. These ecotypes are defined by a combination of physical characteristics, dietary preferences, social structures, and vocal dialects. They do not interbreed, even when their ranges overlap, suggesting reproductive isolation that has persisted for thousands, perhaps tens of thousands of years. In the North Pacific, three main ecotypes are recognized: residents, transients, and offshores. Resident orcas are fish eaters, specializing almost exclusively in salmon. They live in large, stable pods, vocalize frequently, and travel predictable routes along the coastline. Their bodies are slightly smaller than other ecotypes, with rounded dorsal fins and distinctive saddle patches. Transient orcas, also called big killer whales, hunt marine mammals, seals, sea lions, dolphins, and porpoises. They travel in smaller, more fluid groups, often just 2 to 5 individuals. They are quieter than residents, vocalizing less frequently to avoid alerting their prey, which can hear underwater sounds. Their dorsal fins are more pointed, their saddle patches darker, and their bodies slightly larger and more robust. Offshore orcas are the least understood ecotype. They travel far from shore, feeding primarily on sharks and large fish. They have been observed with worn teeth, possibly from feeding on rough-skinned prey like dogfish. Their social structure and vocal patterns are still being studied, but they appear to form large, loose aggregations. In the Antarctic, at least 5 ecotypes have been identified, each with distinct hunting strategies and prey preferences. Type A orcas hunt minke whales in the open ocean. Type B orcas specialize in seals on ice floes, using the wave washing technique described earlier. Type C orcas, the smallest ecotype, feed on Antarctic toothfish in the pack ice. Type D orcas, recently confirmed as a distinct population, have a more rounded head and smaller eye patch, and they appear to feed on fish in the deep Southern Ocean. Each of these ecotypes occupies a different niche, reducing competition and allowing multiple orca populations to coexist in the same region. In other parts of the world, additional ecotypes are being discovered. In New Zealand, orcas feed primarily on sharks and rays, using their tails to strike stingrays and flip sharks. In the North Atlantic, different populations specialize in herring, tuna, or seals. Off the coast of Argentina, the strand-feeding orcas represent their own unique culture, a behavior found nowhere else on Earth. The diversity is astonishing, a testament to the orca's adaptability and intelligence. Each population has developed its own way of life, its own traditions, its own identity. They are not a single species in the traditional sense, but a family of related populations, each following its own evolutionary path. This diversity has important implications for conservation. Protecting orcas cannot be a one-size-fits-all approach. Each population faces different threats, has different needs, and requires tailored strategies. The southern residents need more Chinook salmon. The Antarctic Type B orcas need stable sea ice. The transients in the North Pacific need healthy populations of seals and sea lions. Generic conservation measures will not work. We must understand each population on its own terms, respecting its unique culture and ecology. This requires long-term research, detailed monitoring, and a willingness to protect not just the whales but the entire ecosystems they depend on. The genetic differences between ecotypes are significant. Studies of mitochondrial DNA, which is passed from mother to offspring, show that some ecotypes diverged over 100,000 years ago, possibly longer. This is deep time, evolutionary separation that predates modern humans. Despite living in the same oceans, sometimes in the same waters, these populations have remained distinct, suggesting strong behavioral and cultural barriers to interbreeding. They speak different languages, hunt different prey, and follow different social norms. To an orca, another ecotype is not just different. It is foreign, perhaps even incomprehensible. This cultural and genetic isolation is what drives the proposal to split orcas into multiple species, recognizing the reality of their diversity. The life of an orca begins in darkness, deep within the mother's body, where it grows for 15 to 18 months, one of the longest gestation periods of any cetacean. When the time comes to give birth, the mother slows her movements, staying close to the surface. The calf is born tail first, a common pattern among marine mammals, preventing drowning during the birth process. As soon as the calf emerges, the mother or another pod member guides it to the surface for its first breath. That first gasp of air is critical, the beginning of a life that will be spent in constant motion, constantly breathing, never able to fully rest. Newborn orcas are large, typically 8 to 8.5 feet long and weighing around 400 pounds. They are born with a yellowish or orange tint to their white patches, a coloration that fades to white within the first year. Their dorsal fins are floppy at birth, folded over from being cramped in the womb. But they straighten within weeks. From the moment of birth, the calf stays close to its mother, swimming in her slipstream, conserving energy as it learns to navigate the ocean. The mother is patient, slowing her pace, surfacing frequently to allow the calf to breathe. She nurses the calf with rich, fatty milk, providing the nutrients needed for rapid growth. Nursing continues for 1 to 2 years, though some calves may nurse longer, especially if the mother does not have another calf soon after. The bond between mother and calf is immediate and profound. The calf learns to recognize its mother's voice within days, responding to her calls even when separated by distance. It learns to breathe in sync with her, to follow her movements, to trust her completely. This trust is essential, as the calf is vulnerable in its early months. It cannot hunt, cannot defend itself, and must rely entirely on the pod for protection. Predators are few, but threats exist. Sharks, particularly great whites, have been known to attack young orcas, though such incidents are rare. The greater danger comes from environmental factors: cold water, storms, and lack of food. If the mother is malnourished, she may not produce enough milk, and the calf can starve. Infant mortality is highest in the first year, when calves are most vulnerable to these threats. As the calf grows, it begins to explore, venturing short distances from its mother, interacting with siblings and cousins, learning the social rules of the pod. Play becomes an important part of its life. It chases fish it cannot yet catch, practices breaching, and mimics the behaviors of adults. Through play, it builds the strength and coordination needed for hunting, develops social bonds that will last a lifetime, and learns the cultural norms of its family. By the time the calf is weaned, it has already absorbed much of the knowledge it needs to survive. The calls of the pod, the basics of echolocation, the locations of hunting grounds, and the social hierarchy within the matriline. Adolescence in orcas, roughly from age 2 to sexual maturity, is a time of intense learning. Young whales begin to participate in hunts, though their contributions are often minor. They watch, learn, and gradually take on more active roles. A young whale learning carousel feeding, for example, might start by simply swimming with the pod, observing how the adults coordinate their movements. Over time, it begins to help herd the fish, learning the timing and positioning required. Eventually, it participates fully, striking the fish ball with its tail, feeding alongside the adults. This learning process can take years, sometimes more than a decade, for the most complex techniques. There are no shortcuts. Knowledge is earned through experience, through trial and error, through patient observation of elders. Sexual maturity arrives at different ages for males and females. Females typically reach maturity around 10 to 13 years of age, though they may not have their first calf until their mid-teens. Males mature later, around 13 to 16 years, but their physical growth continues for years after. A male's dorsal fin continues to grow throughout his life, eventually reaching its iconic 6-foot height. Males also develop thicker bodies and more pronounced saddle patches, making them easily distinguishable from females. Despite reaching sexual maturity, males remain with their mothers, seeking mates from other pods during social gatherings, but always returning home. Females give birth every 3 to 10 years, depending on environmental conditions and the health of the mother. Calving intervals are longer when food is scarce, as the mother needs time to recover between pregnancies. In healthy populations, a female might have 4 to 6 calves over her reproductive lifetime. Not all will survive to adulthood. Those that do will carry forward the family's genes, its culture, and its traditions. Females stop reproducing in their 30s or 40s, entering their post-reproductive years, but they continue to play vital roles in the pod, as we have seen. The lifespan of an orca in the wild can exceed 90 years for females, with some individuals possibly reaching 100 or more. Males live shorter lives, typically 40 to 50 years, though some reach 60. The reasons for this disparity are not entirely understood, but it may relate to the physical demands placed on males, the risks associated with seeking mates from other pods, or simply the evolutionary advantages of longer-lived females in a matriarchal society. Whatever the reason, The result is a population structure dominated by females, with older females providing the stability and knowledge that younger generations depend on. Death comes quietly to most orcas. They do not have natural predators. They do not succumb to old age in the dramatic ways that land animals might. Instead, they simply slow, weaken, and eventually stop. Pod members may stay with a dying whale, vocalizing, touching, perhaps saying goodbye in ways we do not fully understand. When a calf dies, mothers have been observed carrying the body for days, sometimes weeks, refusing to let go. This behavior, seen in several species of cetaceans, suggests a depth of emotion, a capacity for grief that challenges our understanding of animal consciousness. It is a reminder that orcas are not just sophisticated predators or fascinating subjects of study. They are beings with inner lives, with relationships, with experiences of loss and love that may not be so different from our own. Orcas are creatures of the cold seas, though they can be found in temperate and even tropical waters. The cold is where they thrive, where the food is richest, where the ecosystems are most productive. In the North Pacific, they inhabit the coastal waters from Alaska to California, following the seasonal movements of salmon, seals, and other prey. In the North Atlantic, they range from Norway to Iceland to the coast of Scotland, hunting herring, mackerel, and seals. In the Southern Ocean, they navigate the pack ice, the open ocean, and the sub-Antarctic islands, pursuing fish, seals, and whales. These cold waters are harsh, unforgiving, but they are also abundant, supporting food webs that can sustain large, intelligent predators like orcas. The ocean is not uniform. It is a mosaic of habitats, each with its own characteristics, its own challenges, and its own opportunities. Orcas have learned to navigate this mosaic, moving between coastal and offshore waters, between shallow bays and deep trenches, between ice-covered seas and open ocean. Some populations are highly migratory, traveling thousands of miles each year to follow prey. Others are resident, remaining in relatively small home ranges year-round. The northern resident orcas of British Columbia, for example, travel along a predictable route each summer, following salmon runs through the Inside Passage. The southern residents do the same, though their range extends further south into Washington state. These predictable movements make them vulnerable to disturbance, as boats, fishing gear, and pollution concentrate in the same areas the whales depend on. Orcas are adapted to cold water in ways both obvious and subtle. Their thick layer of blubber, sometimes several inches deep, provides insulation against the chill. It also serves as an energy reserve, storing fat that can be metabolized during times when food is scarce. The blubber is not just passive insulation, it is actively managed by the whale's circulatory system, which can shunt blood flow to the skin to release heat or pull it inward to conserve warmth. This thermoregulatory system allows orcas to maintain a stable body temperature even in near-freezing water. Their large size also helps. Larger bodies have a lower surface area to volume ratio, meaning they lose heat more slowly than smaller animals. This is one reason why orcas, and marine mammals in general, tend to be larger than their terrestrial counterparts. The cold seas are also acoustically rich. Sound travels faster and farther in cold water than in warm, making echolocation and long-distance communication more effective. Orcas take advantage of this, using sound to navigate, hunt, and socialize across vast distances. A call made in the fjords of Norway can be heard miles away, allowing pod members to stay in contact even when out of sight. This acoustic landscape is part of the orca's world, as important as the physical geography. But it is also increasingly threatened by human noise. Ship engines, sonar, and industrial activity create a constant din that interferes with orca communication, making it harder for them to find food, coordinate hunts, and maintain social bonds. In some regions, the noise is so pervasive that orcas must call louder to be heard, expending extra energy and potentially suffering from stress. Orcas do not migrate in the traditional sense, where an entire population moves from one region to another with the seasons. Instead, their movements are fluid, opportunistic, driven by the availability of prey. When salmon are running, resident orcas congregate in the rivers and estuaries where the fish gather. When herring arrive in the fjords, Norwegian orcas follow. When gray whale calves begin their northward migration, transient orcas position themselves along the route, waiting for opportunities to hunt. This flexibility is a strength, allowing orcas to adapt to changing conditions, but it also makes them vulnerable. If prey populations decline, if habitats are degraded, if the rhythms of the ocean are disrupted, orcas have fewer options. They cannot simply move elsewhere. Their knowledge is place-specific, their cultures tied to particular regions and particular prey. Protecting orcas means protecting the entire ecosystem they depend on, from the smallest plankton to the largest salmon, from the cleanest waters to the quietest seas. The relationship between orcas and their environment is not one way. Orcas shape the ecosystems they inhabit, a phenomenon known as top-down control. As apex predators, they regulate the populations of their prey, preventing any one species from becoming too abundant. This has cascading effects throughout the food web. In the North Pacific, for example, transient orcas hunting sea otters may have contributed to the decline of otter populations, which in turn allowed sea urchins to proliferate, leading to the degradation of kelp forests. This is speculative, and the exact dynamics are still being studied, but it illustrates the interconnectedness of marine ecosystems. Orcas are not just inhabitants of the ocean, they are architects, their presence rippling through the web of life in ways both visible and invisible. The cold seas are changing. Climate change is warming the oceans, altering currents, and shifting the distributions of prey species. Sea ice is retreating, opening new areas to orcas, but also disrupting the ice-dependent species they hunt. Salmon runs are declining, affected by overfishing, habitat loss, and changing ocean conditions. These changes pose existential threats to some orca populations, particularly those with specialized diets. The southern residents, dependent on Chinook salmon, face an uncertain future as salmon populations dwindle. The Antarctic orcas, adapted to life in the pack ice, may find their hunting grounds transformed as ice cover diminishes. Adaptation is possible, but it takes time, and cultural knowledge may not transfer easily to new prey or new habitats. The orcas of the future may look different, sound different, and live differently than the orcas of today, or they may not survive at all. And now, as the night deepens and the waves of sleep begin to pull you under, we come to the end of our journey through the world of orcas. We have swum through icy waters and warm, listened to dialects spoken in the dark, watched hunts unfold with breathtaking precision. We have met grandmothers who carry the wisdom of a century, mothers who teach with patience, and calves who learn the songs of their ancestors. We have seen intelligence that rivals our own, cultures as complex as any human society, and bonds that last a lifetime. You are a part of this ocean, not just a visitor, but a participant in the same forces that shape orca lives. The atoms in your body were forged in stars, the same stars that shone on the first orcas millions of years ago. The water in your cells once flowed through ancient seas, the same seas these whales have called home for longer than humans have walked the earth. You are connected, woven into the fabric of life that stretches from the smallest plankton to the largest whale, from the quietest depth to the brightest surface. Tonight, as you rest, the ocean continues. Orcas are swimming, calling to each other across the dark. Grandmothers are leading their pods to feeding grounds remembered from decades past. Mothers are nursing calves, teaching them the songs that have been sung for generations. Young whales are playing, learning, becoming the next keepers of their culture. And somewhere, in the cold and quiet, a pod is hunting, moving as one, their voices rising in coordination, their bodies synchronized in a dance as old as the sea itself. The orcas do not know we are listening. They do not know we care. But they continue, as they have always continued, living their lives with a richness and complexity that humbles us. They remind us that intelligence takes many forms, that culture is not unique to humans, and that the ocean is home to minds we are only beginning to understand. They remind us that we share this planet with beings whose stories are as important as our own, whose survival depends on choices we make, whose future is in our hands. If you happen to still be awake, you can go ahead and watch the next chapter now. I hope you sleep well and dream of cold seas and ancient songs. Good night.